Hey guys, welcome back. Today's video is a quick update on my current development process of my DC electronic load. You may know that I already made a video and I do have a small prototype. However, I plan to build a bigger one that is actually capable of doing quite a bit of power. And this bigger version is now in development for essentially even before I released the last video in which I essentially explained how it works. Now let's just take a quick look at what I showed you. That was this over here. Now this is the simple DC electronics load using a single op amp of the LM358 and a single IRL 540. And this can be used as it is, but I decided to make a bigger one. You could just use a bigger transistor, but I decided to use just this 4 times in parallel and decided to be able to expand it in the future. The first actual PCB that I made was this one over here, and you may notice right away that I did a mistake. Yeah. Instead of the load resistors, I had normal resistors in place, and that was wrong. So this was version number 1. Then we had the revision number 1, and this was the version that I showed you actually in the video about the DC electronics load. This is what I intend to build. We have 4 times the IRL 540, 4 load resistors, and a potentiometer, 2-pin connector, and 2 LM358s, plus the power supply for the LM358 voltage reference that is generated by this potentiometer. The problem is that here are a number of problems, and I made another revision number 2, which then quickly got replaced by revision number 3. Revision number 2 is not stored. I did just not do that as it's unnecessary. And this is revision number 3, and today we will do revision number 4 and hopefully the final revision. And let's just go over this very quickly so you know what I did and why I did it, and we will also talk about the changes that I'm about to make. So we have 2 LM358s over here. You see that I have for the voltage feedback, voltage feedback as it's called. I call the other one is voltage reference from the potentiometer, feedback from the load resistor, and the gate driving connection. I have a 2-pin connector so I can do easy measurements. Then we have the smaller resistors that I actually called them pull-down resistors, but I was corrected by a viewer that these resistors, they are not pull-down resistors, but they actually suppress oscillation that is happening on the MOSFET gate due to the LM358 trying to constantly change the voltage to have it stable. There's an oscillation happening and the resistor dampens that. I was warned that in some cases a resistor is not enough, so there might be a need of a RL or RC kind of setup. So what I did was I added some pads between the load resistors, so that if the one single resistor is not sufficient, I can easily get other components in place and make an RL, RC or LC circuit, whatever is necessary to dampen the oscillation that might be a problem. So that's the reason for these pads. And I also have a other connection here from the gate, so that I can easily do all the adjustments necessary. Then we have, I already mentioned that the 4 IRL 540s. We have the capacitors across drain and source, because there can also be some oscillation happening. They dampen this oscillation. the standard load resistor, nothing special. And I have two big tracers. These are right now 5.5 millimeter wide. For some reason I have it in millimeters. I'm using typically a thou, as this is just standard when you design PCBs. But yeah, you can in this program convert it to millimeters. So yeah, 5.5 millimeter. Stop it. Or are we using 220 thou? These pads are made, the inner hole diameter is 3.05 millimeters, so there can be a M3 screw inserted, and I intend to use either these ring type crimp connectors or these fork type connectors and a screw to get my cable, my load cable, onto these tracks. I also extended it to the other side because I am not sure how to actually install the PCB in the enclosure. I do have a certain enclosure that I want to use, and I made a dry fit just with the PCB, as this is a standard sized PCB, 10 centimeters or 100 millimeters by 150 millimeters, and this is the standard size that I use. So I made a dry fit, and I'm not sure where I need a connection, so I just extended it to the other side. Beside that, yeah, so then we go over here with, we are talking about this in a moment. Over here we have, you see I'm using 2 pin connectors also for VCC number 2. This is the, I call it VCC number 2 because there are certain names for all the connections, like VCC. This is VCC, but it's our load side positive, and this is our load side negative. Just to get things a bit more organized with naming, I call it VCC-2. And this is the 2-pin connector necessary for the voltage delivery to the LM358. And then we have the 3 potentiometer connections. And as you can see, our voltage supply, the ground is referenced to our load ground. We have our positive going to the LM358s directly. Beside that, you can see that we have another 2 LM358s in place over here, or rather, after etching, we will have a way of installing another 2, and that is in place for eventually future expansion. So I have the inverting, non-inverting, and output of the op amps extended to some pads, and then I intend to use another PCB on top with another 4 RL 540s. So essentially this setup over here just 4 more times, and so I don't have to use a PCB as big, just a smaller one for the essential parts. I decided to have the 2 additional LM358s on this PCB. And I have, as you can see here, the traces are disconnected by these 2-pin connectors. We just have to use some jumpers to actually connect them in the end. And something is not right over here. I have to reopen the project. Did something... what is happening? Yeah, right, everything's fine. So yes, that's that part. This over here is my temperature controlled fan circuit, made in a very, very tight place. Let me just open it. I think I do have it somewhere else. Temperature controlled fan, this over here exactly. And if I remember correctly, I am using, I think, this version over here. Can this be? Nah, doesn't matter. So essentially, the bare minimum version is this one. We have an LM358, a voltage supply from 12 to 30 volt DC. This is a 2-pin header for your fan. R1 is a 1K NTC thermistor, and R2 is, well, it's a fixed resistance, but I think I use a potentiometer. Yes, exactly, potentiometer with a protecting resistor, so that I can precisely set when the fan hits its maximum speed at which temperature, depending on resistance of the NTC. And the NTC is not in place. We do have a 2-pin connector, and I call it a feedback-NTC. We have a 2-pin connector in place for VCC, a marked plus on this side, and we have for each of these circuits 3 fan connectors. I also have another 2 capacitors in place to stabilize the voltage. Now I made 2 of these circuits and copied one just over here, and yeah, so that's essentially revision number 3. I hope I did not forget anything. Oh yeah, and by the way, I marked the load resistors with 0.1 ohm and 1 ohm because you can decide, and I have to see what works best, but I think I will go for the 1 ohm instead of 0.1 ohm, so it's not as difficult to go into the lower current range. Now, this looks fine, but there are a few things that I have to change. Number 1 is there is no way for me to screw the PCB down. Yes, I do have these pads with M3 screw holes in place, but that's not really good. Let's be honest. This is power connection and not fixing it to the PCB, so I have to, get some in the corners or somewhere else. And as I was looking at this, I noticed that, I do have place in this corner, I do have place in this corner. I can make place in this corner. Let me just try to grab all of that. Yeah, not really. I can, yes, right, I can just slide this down a bit, as there is enough space. As you can see, the M357 is oriented that we have the back facing in this direction, so I can have a heatsink installed, and I have to make sure that there is enough space. So now we have 3 of the edges that can potentially be used for screwing it down. And that's the first thing that we're going to do, is we get rid of this over here. We will slide it down to there and essentially recreate the circuit. We are going to recreate it because I decided that I want to have the fan circuit in this area over here, as there is enough space, so I can have actually 4 mounting points in all 4 corners. And we also don't have to do this weird bend anymore. When we just slide this down, that should hopefully be right. Yeah, so like this. So let's first install our new mounting holes. So I select that, copy it over. We have a M3 screw hole in the middle. I want mil. So we have hole diameter 120 mil, and was it this value? Yes, right. So this is, let's change it. Hole 125 mil, just to have a bit more space, and go for 135 mil outer diameter. This is just essentially to mark the points where I have to drill. Then we also rename it. This is mounting, then we copy it and get it over next point. That should be fine. Then next point, and I have to make it different. Mounting -1, so I don't have these lines in between. Mounting -2, we can have mounting and mounting -3. So another mounting hole over here. And rename it -4. Was it -4? No, -3. Whatever. Doesn't really matter. This is just to not have this. So we now have holes in all the 4 edges. Let's see. I would like to have stabilizing holes in between of here, because I will explain in a moment why I want additional holes in a moment. That has something to do with a new setup for the MOSFETs. Essentially, so how they are designed right now is we have the back of the MOSFET facing downwards in this picture, which means I originally decided to have a heatsink over here. The problem is when I test fitted the PCB, I noticed that I could do it, but I would just waste so much space, as the enclosure that I intend to use is very high. So what I'm going to do now is change this setup over here so that I can in the end lay this IRL 540 facing the PCB. If we take a look over here, now this is essentially how a transistor MOSFET looks like. This is the back side that is in the picture facing down, and the front side is this here facing well, the opposite direction. And I intend to have the front side facing down on the PCB. They will be bent at these joints where the bigger leg part comes down to the smaller, thinner leg part. It will be bent in a 90-degree angle so that the package sits onto the PCB, and I have to reroute this trace and maybe even this trace so that I can in the end, as soon as I know where the screw hole is to put, put a screw hole in without having a problem with these traces. And I will also slide the capacitors further down, and I think I will just install them. No, I'm not thinking. I will definitely install them underneath the PCB. They don't have to be on the top of the PCB. They can also be underneath. They just have to be in place. So we'll install them underneath so they don't obstruct the MOSFET if laying down. What this also allows me to do is have a heatsink going over the whole PCB. But I'm not going to do that. I yet have to figure out if the load resistors need cooling. I don't think so, but I will definitely do a few more calculations, and as I intend to have them facing down, so this side, the back side, looks upwards, which is essentially the side that you need to connect to a heatsink. We have no problem, as I can simply extend the heatsink then over these load resistors. But that's just something for the future. Right now I have to change this setup as well. But let's start with the fan circuit. So I will rearrange all the components so it fits inside of here without any problem. I want to have 2 fan circuits as well. The thing is, with a single fan circuit, you see I can install 3 fans. They are intended for 3 fans. They or rather they can have. The 317, the LM317 can handle up to 1.5 amp. As I have to drop from an unknown voltage because I don't know the reference voltage I'm going to use, at least not yet, and a fan essentially uses 200 milliamp. 600 milliamp is not is the maximum I would like to load a single LM317. And because I only have a single, well, feedback from one NTC, yeah, it should be fine, but it would be nice to have another fan circuit. And essentially the first, so the design right now is that I have two fan circuits, and each fan circuits, oh my god, each fan circuit powers one single fan, and they can be excited with another two. That's the idea. So I can have, let's say I can have a temperature probe over here and a temperature probe over here, so that I am sure that there's enough cooling, and maybe I have one fan here, or that's something I have to figure out. That's not 100% sure. It's still a work in progress thing, so let's just rearrange these components and see if we can't get this thing to fit. Let me just check for a moment what the initial problem would be. Actually, we can fit it in here. We don't really have to change much. The thing is, I would like to have a bit more space to the outside, and this is also a bit tight over here. So yeah, let's just well, let's just do it real quick and see what I come up with. I think I will just speed this part up to whatever speed, and we will see in a moment when I'm finished. Alright, I think I have the circuit correctly connected. So I had to rename all of them. Well, I wanted to rename them as the additional lines between the two circuits just were too irritating. So now hopefully everything is set up correctly, and I can slide it a bit into this direction. We have enough space. Now let's stay over here. Now we can go. Yeah, that should be fine. We have enough space on top. We have enough space on the bottom. Here it gets hot, but we do have. Let's see. Go millimeter. Let me just make a quick measurement from here to here. We have. Stop it. We have approximately here, approximately a centimeter distance. That's more than enough. A small heatsink will fit inside of here. We have this circuit that can, yeah, that can stay as is. Beside that, this is not a problem that it's so close. This is not a problem. Yeah, I think we are done with that part. Now, as for additional screw holes, I will... Oh no, stop. Before I do that, I have to change this area over here. So yeah, I'm going to make a bit of space in the middle over here. When we take a look, that's wrong. Here you can see middle pin lines up with the screw hole. We need an M3 screw, so we can use that as a reference. And as you can see, yeah, over here it needs to have more space. So we'll have this going out a bit, have going this to the side a bit, and I will slide this down. So I have to get rid of all of these. I will slide the connection further down. Yeah, I think that is how I'm going to change all of them, so that when I lay this thing down I can go all the way up here and screw it in place. I'm not sure. Well, let's just see. The maximum length I need from the edge, so from here down there. Let's see how much space we have. We cannot screw in over here. Oh yeah, the last screw hole can be made, let's say, at this height. So let's just guess the maximum length in the middle, these holes. So I measured this to be maximum 2 centimeters or 1.9 centimeters, so 90 millimeters. Millimeter trace length 17.99 millimeter. Oh, wait. Screw hole position. I can just quickly measure screw hole position. That is a quick thing. Let me just grab an IRL 540 and my caliper, wherever it is. Middle of the screw hole is 11 millimeters, so 1.1 centimeters. 1.1 centimeters. From, let's see, from here to the screw hole, maximum 11 millimeters, and we are 17 millimeters long, so we have more than enough space. I will just keep it as is. We can remove the reference, and I'm going to redo it for all of these traces. And when I'm finished, we'll come back and insert the last few screw holes, and then we are done, and I can finally etch the PCB. Alright, I think I have all the traces done correctly, and hopefully they are all similar. It doesn't really look too good, but hopefully it works. That's the most important thing. Now let me just use this as a reference, and we will see if we can make the traces a slight amount bigger, just to potentially have a bit more current capability. I'll use just 2 of these things as reference, and we can see how tight we get. Let's just go back to mil or thou, and then let's just 60. How does it look with 80? 80 looks good. 80 thou, perfect. 80. Yeah, that's all right. We don't need more. It's just to squeeze a bit more out of the tracers. As we, when we etch, we remove the copper material that is already in place. So why not go for bigger tracers? But going for more than 80 mil, or what is 80 mil? Let's see. 2 millimeters. That's more than enough. I mean, again, I'm going to have solid core wire on top. Let's go for mil again. That's all right. Very big traces right now. These capacitors will be installed below the PCB, so underneath. I will let everything be as is. Then now closer to the MOSFET will be installed underneath the PCB, so they are not on top. We can easily have it lay on the PCB, so the front side facing the PCB, the back side facing upwards, and then we can attach a heatsink. We have now space in this area over here for screw holes. If I just use this as a reference, essentially the middle of our the gate, which is essentially over here. From here to yeah, approximately like over here we can make holes, and I hope that this is fine. Again, I measured with a caliper. I will approximately need 11 millimeters of space, so we should have enough space, but I can always... I measured wrong. Oh no, I measured completely wrong. Let me just rethink this. Okay, the hole needs to be at 15 millimeters away from the gate. 15 millimeters, so 50 millimeters away from the gate. Let me see. Middle, gate, middle, approximately like this. How long is this part? This is length 12. Oh, we need another 3. Like, oh, hopefully it fits. Like this. How long is it? 17, so it's actually 16. Yeah, so let's say approximately over here. So the hole needs to be approximately here. So yeah, we have enough space. That was just to validate that. We don't need 11 millimeters, we need 15 millimeters. So it's always good to double and triple check what you think is going to work. And if not, I will come with something. But I think now I have everything wired accordingly and connected accordingly. And that thing is weird. What is happening? Can we please... Yeah, what is going on with this? I don't know, what is this? Can we have these things removed, please? Thank you. So how big is this? Oh no. In foul place, we are... What? 220. Yeah. 220. Can we please remove this? Thank you. Now everything is properly aligned. Load negative writing, load positive writing. And yeah, so now we have these mounting areas. And the last thing to do is to install a few more mounting holes. And as I will have a heatsink on this area over all of the MOSFETs, I need mounting holes for the heatsink. So that is the last thing to do, is install some mounting holes. And I think I will just do it like this. I will probably align them once they are in place, and then I have to again check everything, but that will be off camera. And the next thing, the next step for this project is to actually etch the PCB. Now I just noticed that I don't have space for mounting over here. What can I do? Yeah, I'll think about anything else that I could install over here or here, but I don't think that this will be very interesting. So yeah, that's essentially it. Everything that I might fit in here is if it is interesting, I will tell you. but if not, well, you will see as soon as I etch the PCB. So thank you for watching, and if you like this video, please leave a like, comment down below, and other than that, thanks for watching and see you next time. Bye!